Using a quadratic function to model projectile motion. Take a look at this video. That's some impressive kick. A number of questions come to mind. How far down the field did the ball go before it landed? How high in the air was the ball at its highest point? How far down the field was the ball at its highest point? And we're going to use a quadratic equation to model and answer that type of question. Here is an example taken straight out of the online text. Pause the video, read through the question, and know what it's asking. The first thing we need to do is to enter the equation into the calculator. Hitting the y equals button, we will simply type in the equation. Y equals negative, and I always put my fractions in parentheses when I'm working with the calculator. This way the order of operations is preserved. So negative 625, close parentheses, x squared, plus 3x, plus, and once again, parentheses, 5 divided by 2. Of course, that could have been a 2.5. The next thing is to set the window. Right now, the calculator is set at the standard setting. We really don't need to go much before he kicks the ball. And I have no clue how far down the field, but if he's standing at the 30-yard line, he's got 70 yards with which to go, so I'll give at least 70. And because it's a football field, I'll mark it off in increments of 10 yards. I have no idea how high a football goes. Now, for the negative number, it certainly won't go below 0, but I am going to go to negative, I'll go 30 in this case. I do that so I have a margin at the bottom of my screen. And then for a maximum, I'm just going to guess 100. If I need to adjust it later, I'll adjust it later and do it in steps of 10 feet. And then I'll take a look. How does this look? That looks like a reasonable enough picture of this graph. So a reasonable domain would be anywhere from 0 to 70 yards. And a reasonable range would be from 0 to, I don't know, it looks like a 50 or 60 feet. Here's the questions again, in case you forgot. What's the vertex of this parabola? And what are the practical meanings of the coordinates of the vertex in this situation? To find the vertex, we need to find the highest point of the curve. That is found by using second, calc, and look at my choices. The highest point, of course, would be the maximum. When I hit 4, it asks me a question. Where's the left bound? That means take the cursor along the curve somewhere to the left of the highest point and hit enter. Then it asks for the right bound. That means take the cursor somewhere to the right of the highest point and hit enter. Then it asks me to guess. It's not so important in this context where to guess, but I put the cursor on what it looks like the highest point, and I hit enter, and it tells me the maximum is at 29.29 for the x, and the y is 46.445, etc. That tells me 29, almost 30 yards away from wherever Chris Moore punted the ball, it reached a height of 46.5 feet. Back to the question. What are the horizontal and vertical intercepts? And what is their significance in terms of this model? Well, let's take a look. Well, the horizontal intercept, one is here, the other is here in the negative area, which has really no meaning in the context of this problem. But here, where does the y value become equal to 0? Back to second, calc, 0. That's option number 2. Second calc, 0. Again, it's asking for a left bound, which means put the cursor somewhere on the curve to the left of where it goes negative. And then when it asks for the right bound, put it to the right of where it goes negative. And as a guess, put it right where it looks like it goes negative. And there we have it. 59.415 and a bunch of other stuff, 0. In other words, pretty much about 60 yards away from where the ball was punted, it hits the ground. Now, to find the vertical intercept, which is over here, a different trick is used. We're going to use second calc, and this time option 1, value. That vertical intercept is when x is equal to 0, and when x is equal to 0, the height is 2.5. Oh yeah, let's look at the equation. If you put in 0 for x, x squared becomes 0, that whole term becomes 0. 3x becomes 0, so the only thing left is this 5/2, which is the same as 2.5. The last part of this question is, how far down the field from the 30-yard line is the ball when it first reaches 45.5 feet above the ground? Well, let's take a look at this. In order to answer this question, I'm going back to y equals. And in the second equation, I'm going to put y equals 45.5 feet. And just let it be at that, and I graph that. And we say, okay, it comes along and it looks like it hits the curve in many places. I might have to zoom in to see it more carefully. Not that important for us. Right now, I'm just going to go to second, calc, thank you. And option number 5 is to find where two curves intersect. And I hit option number 6, I think. So let's go back to second, calc, 5. All right, the first curve, let's see which curve this calculator, they're too close to, yeah, that's a perfectly good first curve, the quadratic. Second curve, great. Now the guess is important because it will hit the curve at twice, it looks like in this case. So I want to make sure I put the cursor over where I think it hits first. And there it tells me 25 yards down the field from where it was punted, it first hits 45.5 feet. And now it's your turn. Here's another quadratic model. Once again, modeling a football being punted, this time from the 10-yard line, with similar questions that we had before. I'm sure you'll have to go back and forth and look at the video again, but go ahead and answer this one. Ciao for now.